Hello everyone, it's November the 10th. Alright, let's do yesterday's challenge. Oh, it's easy problem, but if it's easy then we probably can have time for this one. Alright, what is this? Remove all adjacent duplicates in string. Given S consisting of lowercase English letters, a duplicate removal consists of choosing two adjacent and equal letters and removing them. Repeatedly make duplicate removes until we no longer can. Return the final string after such duplicate removals have been made. So we remove both an A, C, A, and I see. Isn't that just a stack? I think that's the thing that they're testing these days. Stack it is. Letter in S, if stack. Nah, it's not if stack. It is. It is. I think you only remove it once. Yeah, you remove it once and you remove yourself as well because it's duplicate. So we say if stack and stack is equal to letter, then stack dot pop. Alright. Else stack dot append letter, and then we're gonna return and then join stack. Okay, nothing more to say. $10.47. Use stack. Alright, so that's that. Hand of straights. Alice and Bob again. Some number of cards. She wants to rearrange into groups such that each group is of group size and consists of group size consecutive cards. Give an integer array hand, where hand I is the value written on the ith card, and an integer group size 3. Return true if she can rearrange the cards, or false otherwise. So what we want to rearrange into, each group of size 3 and consists of 3 consecutive cards. 1, 2, 3, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4. I see. Question is the same as 1296. Well, so we sorted first. 1, 2, 2, 3, 3, 4, and 6, 7, 8. Okay. We sorted it. Well, first thing first, we count how many and see if we can be divided by the group size. If it can, then we keep on. If it can, that means every single every single number has to be used, right? Otherwise it won't work. So if everyone has to be used, then everyone needs to be in a group. So now we just go start from front. We say, okay, 1, 2, 3, a counter, right? 1, 2, 3, 4, 6, 7, 8, right? And then 1 is counted as 1, 2 has 2, 3 has 2, 4, and it's like playing poker. And then 1 and 1 and 1, right? And then we just go 1, 2, 3, right? We do one round, and then what would be the easiest way to implement? Yeah, we keep going, right? We do 1, 2, 3, done. And the next one we want to do is see what is the current smallest one. Current smallest one. What will be the easiest way for us to find the current smallest one? We will do. We go back to 1. Okay, we say 1, 2, 3. We put a pointer, right? We put I there, and then we scan 3. So we're done. We come back to I, and then see if it's 0, then move I forward, and then we do 1, 2, 3 again, and then if it is, so we move I forward. Right, and we move I forward, and if it's now, and then forward, forward, forward. Yeah, I think this one will work. A46. Okay, so I want to counter. Right, then what we have a hand. Well, actually, we say if len group size mod, no, len group size, no, that's not len group size, hand group size is not equal to 0, then we return false, right? And then we say counter equals counter hand, and then uniques equals sorted counter, then I equals 0, right? Then we say while I smaller than, maybe we can say, maybe we can do for I in range len uniques, maybe, right? Then we say while counter uniques I. How about this? While counter uniques I. While we have this, then we will say, because it's group size. Oof, group size. Man, that's O(n) squared, man. I'm not sure. Group size. Now I'm not sure. Because you loop through the whole thing. What if the group size is huge? Right? Well. What can we do? What can we do? So we have the smallest, and I need to know. I mean, we can sliding window. How about sliding window? So we start from this, and then we go. We have to do one group size for sure. Okay, so we start I from here, and J just move out, right? J just move out, and then move out up into the group size, and then we say, okay, that's good. Then everybody has to -1. Right? Everybody has to -1. How do we handle everybody minus 1? Hold on, this is not right. I think this will time out. That's another way to go. If we find something, right, and a counter is 1, then we need to know if they're all good. And well, that one we can do in O group size, right? We'll loop through so we know, okay, they're good. And then what? There's 1, right? Then we go to the current smallest is 1. Then 2, current smallest is 2. And then we got 2 again, current smallest is 2. And then we go 3. Current smallest is still 2. Then okay, let's say now we have 2, 3. And then we push 3 in. Current smallest is still 2. Then we push 4 in. Hold on. What are you thinking? Nope. I don't think so. I was thinking prefix, like a range query. I don't think so, because you have to query every single time. That doesn't seem right. Or what if I just loop through everything and occurrences. Okay, so what if I just go through the whole thing? We put it in a set, and if it's 1, if it's first time, I say 1 0, and then 2 0, 3 0, 6 0, right? And 2 again, we put it at 2 1. But why would it? No, it's gonna be 0 1. And then the 4 goes earlier, right? I can sort it the other way. I can do like 1 2 3 4 6 7 8 and 2 3. I can sort it this way. This is what I can do, right? So the first occurrence of everything, I can sort them, and the second occurrence of everything, I can sort them as well. So among the first occurrences, we can definitely hit some stuff. We can like say 1 2 3, we hit, right? 1 2 3. So not really 1 2 3. We just go that much, and then we do a minus, and then see, boom, it works. And since it's only occurred once, so that one is done. And then we do 4 6 7. It didn't work, and then we just move forward, and then boom, something worked, right? And something worked, and then that will be removed. Then we have some value remaining, right? Some value remaining. Then we say we just work on it again. That, would that work? It's the first round, second round. Okay. We might have a third round, we might have a fourth round. Okay, what if I sort them into 1 2 3 4 6 7 8 2 3? All right. And then within the first, we'll go back to front. Okay, we go back to front. Because within everything it's sorted, okay? So it's sorted. So in the first one, go back to front. So whatever is not part. Alright, we go this, we go this, and then if it doesn't work, then we'll throw the part that does not work to the second tier. The second tier. Are you telling me you're gonna sort it again? Then the first round we don't have to sort. We just separate them. The first occurrence into a group, the second occurrence into a group, right? And the third occurrences into a group. And then for each group, we're gonna sort, right? For each group, we're gonna sort, and each group is gonna be unique. Right, we're gonna sort it, and then Now how do I identify the odd one out? Whew. Odd one out. First occurrence. I mean, it has to work on the first occurrence already. Like if in the first occurrence I have something that does not work, yeah, you can just throw it down, which is fine, right? Like this 4, it doesn't work. Oh. The only time you can have overlap, right? So basically we're talking about this overlap thing. We have something that's already done, and then we have an overlap. And the overlapping part is but we can have complex overlap, right? We can have overlap here, we can have overlap here. Yeah, that is a complex overlap. What if we have this type of complex overlap? Well, if this is a type of overlap, what we'll see is this is the first occurrence, right? Say 1, 2, 3, and then 2, 3, 4, and then 1, 2, 3 again, like that. And then we say, okay, 1 first occurrence, and then 1 second occurrence, right? 2 first occurrence, 2 second occurrence, 2 third occurrence, 3, 3, and 3, and then 4 will actually go to the first occurrence, right? And no matter what, because we're lining up this way, and then anything that's first occurrence, so the first occurrence will definitely be on the top layer. So if it's the top layer, then you go through, right? You find this, that's good, and then you move on, find the next one, and the next one is not good, right? Next one is not good. If the next one is not good, keep going. So we mark this, okay? We mark this as not good. Yeah, like because the first layer, right? It has to, if the start is not good, like this, right? If it's 1, 2, and 4, and then we have to go 3, because this is the first layer, right? Nothing should be ahead of it. Nothing should be ahead of it. So we're saying that it's the first layer, and the only bad thing can happen to the first layer is the overhang, right? Is the overhanging part, right? Yeah, because this first layer, I have the second layer, I have the third layer, I have all these layers, right? Eventually, what we're gonna have is all the layers if we have the repeats, right? If we have the repeats, it's gonna be all these layers, and then within each layer, right? Within each layer, and actually in this one I should go like this, right? be like this. That's one layer, another layer, third layer. This won't be here. All right, so within each layer, it shall be good, right? The first occurrence of everyone, right? And then we go, and once we're done, we try the next. And if it's not good, if there's something that's not good, then we say the front of that something is not good shall be pushed to the next layer, because that could be the overhang, right? So we run first round and then we move on. But if the first one doesn't work, right? If the first one, like the first occurrences of everything, and if they don't work, then there's no point. Yeah, the first occurrence has to work, right? And then we go for the next round, and then we have something that's not working, but that something's not working could make work, right? If we have the second layer. Okay. Then if it's not working, whatever is not working, push it down, move forward. Still not working, push it down, move forward, right? And then go to the next round. If we go to the next round, yeah, it could occur twice. So we'll sort it again. Yeah, that's the first occurrence, that's the second occurrence. So if we have multiple occurrences, that's the first, that's the second. So they'll just move on to the second one. Then they're not unique, right? The first occurrence, and then I have two occurrences of this. Okay. What if we have this, like 1, 2, 3, 4, and 2, 3, 4? Then that's a no good, right? And that's no good because each layer has to be unique. So we 1, 2, 3, and then we go 4 to the end. Then everything here needs to be pushed down to the next layer, and then it comes down to the next layer. Then we have a duplicate. That's interesting. Nah, I'm not 100% sure. I'm not sure where I'm going with this. Again, I can counter it, right? And then I put everything with 1 into the first, everything with 2, right? So we kind of spread them out, okay? So that's still all on. We spread them out, and then within each we'll sort, and anything that's not good we push it to the next one, and if there's a duplicate, then we are doomed, right? We're doomed, because not supposed to be a duplicate, because you're supposed to use every one at each layer. So we're pushing down, and then as a duplicate, that's no good. But if there's no duplicate, we sorted it, and we do it again. We sorted it. Not sure. This is still good. This is still good. But we don't sort it here. Then we just say, oh Lord, what do we say? We can say we'll have layers, right? We have layers. And we're gonna have layers, and then we say for that key value encounter dot items, right? we say if len layers is smaller than v, layers dot append a this, and no, I want to do a set, and then layers v, right, -1, because if it's a 1 we have only 0, right? And if it's 2, oh, 2, no, it should be 4. Yeah, for I in range v, then layers I dot add k, right? These shall all be unique, right? They'll all be unique. Now once we're done, we say for I layer in enumerate layers. Okay, for each layer we're gonna say layer dot sort, right? I'm gonna sort them. Then we have for j, hold on, how do we say? Okay, if this is not good, if we have a range that is not good, then we're gonna move one at a time, right? One at a time until we find something good, and the not good part we're gonna push down to the next layer. Okay. So we layer will sorted it, and then we have I and j, right? Or we say this to the end is good, then to jump in here, and this to the end is not good, then we jump in here, right? Okay, we can say I equals 0. No, I use j equal to 0. J is smaller than len layers minus group size, right? Because if it's 4 minus 3 is 1, so it can go and go 0, because we cannot, well, actually we can go, right? 3, because the last one is this one, so that's actually -1, no, +1, because we can go, so 1 2 3 4 5 minus 3 is 2, yeah, or actually it will be easier, we can just say equal to, right? Then what do? We say if, because it's sorted, we say if layer, no, not layers, it's just layer, if layer j, right, plus group size 0 1 2 -1, right? Yeah, if this minus layer j, right? So it's like a 1 2 3 minus this is equal to group size -1. Then if that's the case, then we'll say j plus equal to group size. We just move on, right? Say if else, if it's not, that means we have the current, so we have j plus this minus layers j, right? Well, minus this, and then this part is not right, then j need to plus equal 1, and we need to add, we need to put j to the next level, right? We need to put j into next level. Then we say, what do we say? We say if I, right? If I plus 1 is smaller than layers, which means we have a next level to rescue, so we put it down, right? We put it down. And layer j is not in layer s I plus 1. That means the next level I can accept it, right? If that's the case, then we say layers I plus 1 dot add I just realized this layer is a set. Set doesn't have sort. So I'm gonna say L equals sorted layer. So all the layer here need to be, actually no, it's just this. These are L, right? And then this is L, not in layers. Yeah, that's fine. So this one gonna add LJ, right? Layer J, and then move on. Else, which means we don't have any more room to go, or the next one already contains, and then we have a duplicate. What I say is if we have a duplicate, then they're definitely not going to work. Actually, I'm not quite sure about this, because if we only have, yeah, we could have like 1, 2, 3, 4, 2, 3, 4, 2, 3, right? These are occurring 2 times. There's the first time occurrence, second time occurrence, third time occurrence, right? So we go 1, 2, 3, then I have 4. That 4 needs to go here, and this 4. You know what? This is actually not true. I would just say if we have enough layers, right? If we have enough layers, then we will add it to the next one, right? If we have enough layers, we'll add to the next one. Well, now that, do we even need to make it into a set? Because we're gonna sort it anyway, right? Now I don't think we need a set. I can just use a this, right? And I can just append it, and then I can just do layer dot sort, right? Then all of this will go back to layer. This will be layer, and then we can just append layer, right? Else, if it is, then we add it. If not, which is basically just saying we're gonna return false. We're just saying we have no more room to go, right? And then we'll go back, try it, it's no good, then we'll put in the next layer, play the next layer, and then eventually we're gonna return true, which means we go through all of them. Alright, let's try this. Yeah, it's actually harder than I expected. I thought this one I will blow through this one. This is such a simple problem, very straightforward. It's actually a good one. I like this one. Really like this one. I mean, I have a few. That's a false. Nah, come on, they don't give me this. They just give me true or false. I have a few. Like I have 1, 2, 3, 4, 2, 3. Right? 1, 2, 3, 4. Which one? 1, 2, 3, 4, 2, 3, and 1, 2, 3. Right? This one should be true. And I also have 1, 2, 3, 4, 2, 3, 4, 2, 3. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4, 2, 3, 4, 2, 3. Yes, that should also be true. Yeah, this is kind of all sorts of overhanging. Hand, group size. Oopsie doozy. That ain't right. Index out of range. What? How? That is bonkers. V is 2. Oh, shoot. That is not bonkers. Dang it, man. Should be a while. Alright, so simple cases I can handle, but can we create some, I don't know. Guess the answer is yes, but those will all be false if you just create randomly. Alright, so if we control is 1 to 10, and yeah, let's just submit it. I don't think it will be easy to come up with edge cases. Now I got it wrong. That's fine. Output is true. It's not even that big. Shall be false, right? Okay, okie dokie. Let's see. Probably for L in layers, print L. Just kind of see how it looks like. Wait, how did I come with this was true? Oh, I didn't sort it. And then we shape the, what if the first one is false? The first one, if it's the first one, right, is bad, then it's bad, because it means, because the overhang, unless we have this and this, then the overhang, no, like you have to hang, something has to happen the first time. So if the first time is bad, it's actually going to be bad. So I'm actually going to add that layer to it, which means if this, right, else, then we need to say if j is larger than 0. So it's not the first one. So if j is larger than 0, and yeah, doesn't matter on this one. So we see what happened to this one. This one's 10. So actually it will be easier to Doesn't make any sense. All right, that's 10. 2 to 11. And then 1, 2, 3. 7, 8. We're missing the last one. Oh, shoot. Oh yeah, I know what's wrong. There's no next one is, and then we do this. J is smaller than this, and if we have overhanging, right, we have something remaining. Because J we always jump, right? J is smaller. Then we do this. If it's good, then J will be plus. Then we say if J is smaller than len layer, which means we have extra thing that we haven't dealt with, and all those remaining is overhanging, right? It's overhang of the first. They shall come to the next level. But didn't we handle this? Like these 1, 2, 3, 4, didn't they handle this? You know what? Let's try this one. Now let's print layer. I thought I handled this, yeah? J is smaller. Oh yeah, this is not supposed to be 2, 3, should be 2, 3, 4. This one should be 2, 3, 4, 4. So no, that's not right. So we say if J is smaller than len layer, right? So we have still some of the remaining. Then all of those needs to go, right? And we say, and also if let me think. Yeah, I think we can do it together here. Hold on. We can do n equals len layer, right? And we can just, this is just gonna be smaller than n. And we say if J is smaller or equal to and this, I jump. Otherwise, I do this. Yeah, there we go. 4, 4. And if that's the case, this one's, yes. That error actually can be detected. Okay, let's try it again. Damn. We have one wrong because true become false. This one's supposed to be true. And I say false. Okay. Don't panic. Six, 7, 8, 9. Right? 10 counts down. 6, 7. That's interesting. 6, 7. Shoot. I can write it down. It's a simple test case. So we have 6, 7, 8, 9, 10. That's the first one, right? 6, 7, 8, 9, 10. And then 6, 7, 8, 7, 7. 4 occurrences of 7. So we have 6, 7, 8, 9. And nothing go with 10. So that's why I say it's bad. But what we can do is 6, 7, 7, 8, right? 6, 7, 6, 7, 7, 8, 7, 8, and 9, 10. Oh, that's good. That's good. Dude. Yeah, you don't have to. You shouldn't. Damn. That changes everything. Okay, so this method doesn't work. So we have to go for the smallest, right? Because the smallest is definitely gonna need. So in this case, we can go 6, 7, right? We go 6 and 7, and see. We can go 6, 7 again. Then we have smallest is 7. Then we go 7, 8. Then we go 7, 8. Then we go 9, 10. So this seems to me. Huh. Maybe I'm thinking about it too complicated. No, I don't think you're thinking about it too complicated. This seems to me that what I can do, let's say we have a counter. 6 is 2, 7 is 1, 2, 3, 4, 8 is 2, 9 is 1, 10 is 1, right? This is what we have. So when we see 6 is 2, then we need to go inside and see 7, right? We get minus 2. Just deal with all 6. And once we deal with all 6, then we have the second one is 7. Then we try to see if we want to deal with all 7. And then we have to go, man, that's just, this is the stupid method. It just seems dumb. You know? It just seems dumb. But hold on, isn't that still just do it once? Yeah, I think it's still do it at once. So we can actually use the stupid method. I struggle so much trying to use a smart method. No. We get into the counter, we sort it, and then we just go from the front, right? So we say the smallest, we go from the smallest, right? And then we just loop through the whole thing, and then we just minus, 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 right? And then we go back to the front, and after that we just move forward. You know what? I'm gonna use the stupid method, not this one, okay? Not this one. And then we can say uniques. Yeah, I think the result is on, is because I'm only getting every value once, right? And we say for I in range, I don't know, for I in range len uniques, right? So while uniques, while counter uniques I, as long as I have something, then for j in range I to I plus group size, right? Then what do? We say counter uniques j minus equal 1. But if counter uniques j, then we do this. Else return false, which means in this round nothing happens. And we'll go through them, right? We'll go from this, all minus 1. Coming back, this is all minus 1. Coming back, boom, it failed. Something failed, return false. If it all works, go back, then we're done, we move on to the next one. Yeah, I do not know why I was thinking about it in such a complicated way. Every value is hit only once. Come on, man. Every value is hit only once. I think this is on. You gotta be kidding me. Oh, shoot. No. Jesus, man. Come on, that's not. All right, that was a mistake. That was a mistake. That was a mistake. This is not right. In range, uniques I. Dear Lord, uniques I plus group size, and then this is j. This is j. Yeah. I don't know what I was thinking. This is not expected. All right, let's try this one. Yeah, like, I don't know, it's such an easy one, and I got stuck for so long. Yeah, this is a very easy one. This is an easy problem, but I wrongly assumed that my initial idea was not on, but it was. We use a counter, right? And then brute force it through. By brute force, I mean we go through each possible consecutive group size number of ranges, right? And if any such range lacks a value, we return false. If we can go through the entire, the entire counter, we return true. Now, the key is to realize that as we go through the counter, each occurrence of the value is visited only once. This means we only visit this means the runtime, the time complexity is only on. Yeah, that's so strange that I got stuck. Oh, we have this, which means I think they have better complexity. Number of different cards. Yeah, this. Okay, so ON plus M log M, yeah, where N is the total number of cards in hand. Oh, I just say N equal to len hand, and M is the number of unique cards. All right, such a bad performance, but we got it done. We got it done. Move on. I'm not doing another one, but oh, nice. I'm gonna have a difficult one. All right, that will be it for today. Well, that was for yesterday. I'll do another one later today. Adios.